Hello! Welcome to today's lesson on understanding absolute zero. Today we will cover how absolute zero is the lowest temperature that can be reached. We will understand the Kelvin scale, which is the temperature scale based around absolute zero. Finally, we will explore practical applications, understanding the utility of absolute zero in scientific disciplines. Let's get started! Have you ever wondered what the lowest temperature possible is? This temperature is called absolute zero. At absolute zero, all molecular motion theoretically stops. This means that particles have zero kinetic energy. To put it simply, at absolute zero, there's no vibration, no movement, just complete stillness at the microscopic level. Absolute zero happens at minus 273 degrees Celsius. You might think that's not the nicest number, and you'd be right. That's because the Celsius scale is based on the freezing and boiling points of water. The freezing point of water is 0 degrees Celsius, while the boiling point is 100 degrees Celsius. This makes Celsius convenient for day-to-day use. However, when it comes to talking about absolute zero, it's not as convenient. Hence, we use a different scale called the Kelvin scale. The reference point of the Kelvin scale is absolute zero. This means that absolute zero is defined as 0 Kelvin. Note that this means that, unlike the Celsius scale, you can never have a negative temperature in Kelvin. The divisions on both the Celsius and Kelvin scales are equal. This means an increase by 1 degree Celsius is equal to an increase of 1 Kelvin. For example, if I have some water with a temperature of 50 degrees Celsius, which is 323 Kelvin, and I increase its temperature by 1 degree Celsius to 51 degrees Celsius, its temperature in Kelvin will also increase by 1 Kelvin to 324 Kelvin. So, to reiterate, absolute zero is minus 273 degrees Celsius, or more conveniently, 0 Kelvin. Let's apply this to a few specific problems to consolidate our new knowledge. First, let's convert 37 degrees Celsius to Kelvin. We start with the temperature in Celsius and add 273 to convert to Kelvin. When you add 37 to 273, the result is 310. Therefore, 37 degrees Celsius is 310 Kelvin. Next, let's convert 150 Kelvin to Celsius. Start with the temperature in Kelvin and subtract 273 to convert to Celsius. 150 minus 273 gives the result minus 123. Therefore, 150 Kelvin equals minus 123 degrees Celsius. Finally, let's try converting minus 20 degrees Celsius to Kelvin. Start with the temperature in Celsius and add 273 to convert to Kelvin. Minus 20 plus 273 gives 253. Therefore, minus 20 degrees Celsius equals 253 Kelvin. By working through these examples, you should now be more comfortable with converting temperatures between the Celsius and Kelvin scales. Remember to add 273 when going from Celsius to Kelvin, and subtract 273 when going from Kelvin to Celsius. Keep practicing, and these conversions will become second nature. Before we wrap up this lesson, let's consider an application of absolute zero. First, let's highlight that achieving absolute zero is practically impossible, as it requires removing all thermal energy from a system, which is unattainable in practice. However, scientists can try and get close to it. One interesting application of temperatures near absolute zero is superconductors. Superconductors are materials that can conduct electricity with zero electrical resistance. Many superconductors exhibit their remarkable properties at extremely low temperatures, often approaching absolute zero or close to it. One example of this application comes in maglev trains. Maglev trains use superconducting magnets to levitate above the tracks, eliminating friction and allowing for incredibly fast and smooth travel. Maglev trains can reach speeds over 300 miles per hour or 480 kilometers per hour, making them one of the fastest forms of ground transportation. As technology advances and superconductors become more efficient, maglev trains could revolutionize long-distance travel, offering faster and more energy-efficient transportation options. Today, we delved into the fascinating topic of absolute zero and its associated concepts. We explored absolute zero as the lowest possible temperature, where all molecular motion theoretically ceases, meaning particles have zero kinetic energy. We introduced the Kelvin scale, which is based on absolute zero and eliminates negative temperatures. We learned how to convert between Celsius and Kelvin and applied this knowledge through several practical examples. Finally, we discussed how temperatures near absolute zero are used in technologies like superconductors and maglev trains, highlighting their impact on advanced transportation and other scientific fields. Understanding absolute zero and the Kelvin scale not only enhances our grasp of temperature, but also reveals its significant applications in modern technology. Keep practicing temperature conversions and stay curious about how these concepts apply in the real world. See you in the next lesson.